Okay, in most of our electronic systems we have batteries of different sizes, very tiny batteries to large sizes of batteries like this. All these are chemical energy storage systems with quite a lot of long-term usable energy, but these are very poor in delivering short duration large energy chunks. So in those situations, these guys come into the picture where they can deliver short duration large power into your electronic equipment. So for that reason, if I summarize my major area of work is supercapacitors, their applications, and combined products of batteries and supercapacitors like. Okay. Now this is a commercially available large supercapacitor from an American company. Now this is a basic lantern battery which has enough energy to fill about 10 to 12 of these supercapacitors. So what I did a few minutes back was use that battery and I fill this supercapacitor with energy from the battery. Now what I'm trying to see is, can I take a piece of metal, short circuit the battery across this? I don't see even a spark. Now that battery has a voltage of 6 volts with much more energy than the supercapacitor. Okay, these are some extremes of supercapacitors. This is a very large supercapacitor, but this is a very thin profile small supercapacitor coming from an Australian company. Across this range of devices, we can develop many new applications suitable for commercial electronic systems. Now, for example, in one of our patented techniques using this type of supercapacitors, we have come up with some power management techniques where your battery runtime can be increased, because that way we reduce the waste in electronic systems powered by a battery pack. Okay, now in the power supply voltage regulated technique patented by us, we use these supercapacitors for extending the runtime of the battery. For example, you are in a very long couple of conversations using a cell phone, you would like to have 4-5 minutes extra to run another conversation, then you suddenly see the battery is going to be dead. That is the time where your last bit is so important in the energy storage in the battery. So what we try to do is, how can we extract that remaining last bit without wasting that in power conversion electronics. So that's one of our work going on with several PhD students, etc. If you are a cellular phone company, if you give us a phone with the existing technique with the longest runtime battery and the option to insert our technique of this supercapacitor based voltage regulators, we will modify the low dropout regulator powered area to increase the overall battery runtime by minimizing the losses inside the cell phone. So the challenge is, if you show us the sort of basis to sort of insert this, we will show you how you can get more out of your battery pack. We are involved in multiple areas of research. If I take the area of supercapacitor applications, one area is high current voltage regulators, where the efficiency of the power supply can be improved while maintaining the quality of DC rail. So that was some work we did in 2008 to 2010 and so on, where we were granted a US patent early this year. Then another area we are developing is surge resistant uninterruptible power supplies based on supercapacitor energy storage. So that area of work will be very attractive to the companies who will be selling products like uninterruptible power supplies, power quality products, etc. in worst case power quality situations like the countries around the equator belt, or where there's severe lightning phenomenon around the surroundings, etc.